Hi there, this is a quick video to finish off our understanding of the power rule and how it might be used. So here you can see what we've got so far. We've got f of x equals x to the power of n, then f dash of x is equal to n times x to the power of n minus 1. F of x equals a times x to the power of n, then f dash of x equals na, so we times the power times the coefficient together, and it's x to the power of n minus 1. And we've got f of x equals c, so c is a constant value, no variable of x involved at all. Then f dash of x is equal to 0. So that's what we've got so far. The last part of the rule we've got to look at is f of x equals g of x plus k of x. So f of x is the sum of two other functions. Now, I could have said 3 or 4 or 5 or 6 functions, but I'm just, if it works for 2, it works for more than 2. And that sounds more scary than it really is. I'll give you an example of a function which is made up of more than one function. F of x is equal to x squared plus 3x is an example of that. Okay, it's as simple as that. I mean, that's g of x, and that's k of x. That's all it means. So it means that if we've got a rule for the sum or difference, could be a minus, of different parts, then we can utilise our derivatives a little more powerfully. Now I'll give you the rule first and I'll explain what it means. So f dash of x is equal to g dash of x plus k dash of x. In other words, the derivative of the whole function is the same as the derivative of the parts of that function. So it's easy as that, and you can sort of prove it fairly easy using limit theory. So I'll do that on the next page. Yeah, but it's not too bad. So if we say let f of x equal two other functions, g of x plus k of x. I deliberately didn't use h of x because we're going to use h in a second. Then f dash of x is equal to the limit as h approaches 0 of f of x plus h minus f of x, just as the usual limit theory here, all over h. But now I'm going to substitute in. We know that f of x equals g of x plus k of x. So what does f of x plus h look like? Well, it's the limit as h approaches 0 of g of x plus h plus k of x plus h minus, and what's f of x? It's g of x plus k of x all over h. That's the limit of g of x plus h plus k of x plus h minus g of x minus k of x all over h. So I've just taken that negative into the brackets. And now if I just reorder this, you can probably see where we're going with it. H approaches 0 of g of x plus h, just reordering it, minus g of x plus k of x plus h minus k of x, all over h. And I'll just squeeze it onto the bottom here so that it's on the same line, and that's equal to the limit as h approaches 0. I'm just going to split out that fraction now. So I've got g of x plus h minus g of x all over h plus k of x plus h minus k of x all over h. Okay, so this bit here is of course g dash of x, and this bit here is k dash of x, and so that's pretty much it. It's proven from there. So therefore I've got f dash of x equals g dash of x plus k dash of x, and that's basically it. Now that we've solved that, we can now use that knowledge to solve something like 3x squared, f of x equals 3 of x squared plus, say, 2x. Therefore, f dash of x is equal to, so we derive the first term, 3x squared is 6x, and derive the second term, 2x becomes 2. So if the function is 3x squared plus 2x, then the derivative function is 6x plus 2. And we're done.